Today, for week two, we'll be talking about gradient descent. You see here, as in week one, we have the neural network still, but this time it will be different. Instead of doing a neural network with a multi-layer neural network, we'll be doing training data instead. I see here we have the training in process with the one-to-one. The way how training data is works is it shows the the neural network a bunch of numbers, and it just sees those numbers and it does the same thing as like the neural network. It will give you the answer, but we keep feeding it more numbers, so it builds in its mind what a number looks like, or what the number that we have looks like. So in this situation, we have a seven. Well, it was multiple numbers, but as you see here, we have it read 111 times correct out of 115, which giving us a 97% of no training data. And in this next one, the way how it is gathering all the training data is basically like the opposite of um a neural network. It is it is taking the inputs of every neuron that was collected, and it's gonna spit that out whatever number it is. So each line here is a neuron, and for this one it is looking for three on each one. But the difference is that the average is 3.37, and but this one is 0.03. The closer you are to zero, the better the answer. This side is without training data. This side is with training data. You see here, this one has a pure white 3. And it's the lowest number, so close to zero. Means that it is learning more and seeing a clearer picture of the number. While this one here has grays everywhere and white. Also, the numbers average to a 3.37, meaning that it's using the old version, which is the neural network. The way how this is shown is with the cost function, which you see here, the input and the cost is 5.4. It's taking the inputs of the weight and biases of the whole neural network, but it's only spitting out one number, which would be the last one, like the white 3. But the weights and biases is all this. And this is through many examples. See, one to one. This is also done through the gradient descent method, where you have this hill, and you're taking steps slowly down. Well, a ball will be rolling down into the hole, like a hole in one in golf. See here, you have your weights, and then the difference would be the ball will be going down and it'll be taking the steps slowly. See here, it took its first step. Oh, it should increase somewhat. So it'll go down and increase its step. And again, increase a little bit. So it'll go down, increase again. Oh, but then we have a negative. So now we know that the ball needs to be decreased a lot more. So it'll go down a lot more, which is what this gradient descent is showing you. Down, down, down. It will take whatever the weights and biases is of the numbers, and it will make it the average better to a zero, get closer to a zero. So basically, this is like doing everything. It's taking the training data and it's making it easier to figure out what that number is to get to the hole in one. But even so, when you have all this training data, if you give it an image of anything, it's not really learning how to make the seven to create it. It is like someone taking a test and memorize all the questions and then the answers to those questions, and it is just rinse is spewing out of memorization, but you're not learning it. You will probably be given the question again, but you're like, oh, I didn't memorize this, so I don't know how to do it. It's the same thing as the way how this works with the gradient descent. It is getting all the information, or the training data. It is getting all the information, and it's basically spewing out, oh, this was what I saw last time, so it looks like a seven. But in this case, we have no picture of a number. It's just a bunch of things. But since it's taking all that training data, It's like, okay, so this white thing was here before, so let's get it closer. Maybe it'll do something different. Like this white chunk is here, it'll do something different. It would basically be like the neural network again, but it would just say, I guarantee this is a five, but it is giving you the answer of a five. Well, there's no five there. It's because it's just memorizing pictures, and it's like, okay, I memorized something like this before. I'll give it to you, and this is what it looks like. So meaning that this is not really a great way for you to get the answer every time, as it is only guaranteed if you're giving its job for the purpose of finding numbers only, and the picture will be has to be like somewhat of a clear number, and that'll be it for week two.